Okay, example 3.2 is located on page 3 of your PowerPoint notes, and it's just doing the same thing that we did previously. It's just another example. So we can look at 41.9 grams of ammonia gas. That's our first ingredient. Okay, so it's 41.9 of NH3, and the other reactant has 87 grams of iodine gas. So it says divide both quantities by their molar mass, and NH3's molar mass is 17. Alright, and iodine's molar mass is 253.8. Alright, so then you'd punch that into the calculator, and the answer was 2.46. Alright, and this one's answer was 0.343. Alright, and it says divide this answer by the coefficient of the balanced equation. So NH3 has a coefficient of 2, and I2 has a coefficient of 3. Okay, and when you punch those in the calculator, this one ended up 1.23, and this one ended up 0.114. This number is smaller than that number, so this was the limiting reagent, and this was your excess, the one that was in excess. Meaning that if this reaction occurred, what you think is pure, this stuff on this, like in the test tube or whatever, there's still some NH3 unreacted left over in that mixture. Okay, in the next example, which is on page 3 of 4 in your stoichiometry notes package for chapter 9, this is talking about limiting reagents, and hopefully you've watched the rest of the PowerPoint to see what limiting reagents are about, or you can certainly look in your textbook for limiting reagents. You look in the index, find the page number. But basically it's saying that you could have too much of one ingredient, not of another ingredient, and how much of these is made depends on the one that you have the least of over here. Okay, so it's very simple that they're basically going to give us amounts of both reactants. So zinc, they said that they had 0.95 grams of that, and they had 11 grams of the other reactant, HCl. Okay, so in column 1 you just put the name of the first reactant and its amount that they have, the name of the second reactant and the amount that they had. Okay, alright, then what you do is you find the molar mass of zinc, and the molar mass of zinc can be found pretty easily on the sheet, 65.4. Okay, so you go 65.4, and then do the same with your other reactant, HCl. HCl's molar mass is 36.5. Okay, alright, and that's going to equal something. Okay, and I'm not going to punch that in the calculator, I've already done it, but this answer was 0.145, and this answer was 0.301. Alright, then it says divide the answer of column 2 by the coefficients of the balanced equation. So the balanced equation has a 1 for the zinc and a 2 for the HCl. So I do this, divided by 1 because we're in the zinc, alright, and divided by 2 because we're doing HCl in this row, alright. And punching that in the calculator, 0.145 divided by 1 is 0.145, and 0.301 divided by 2 is 0.150. So this number is less, so we call that the limiting reagent, and we say the other one is available in excess, meaning that when this reaction is happening and the products are made, there's still a little leftover HCl in the test tube. So if you can imagine a test tube, and you put some acid in there, and you dropped a piece of zinc in there, and it bubbled and made hydrogen gas, and all the zinc seemed to disappear. Well, be careful, because there's still some HCl in there that never reacted with the zinc. Okay? Okay, example 4.1 is located on page 3 of 4 in your stoichiometry notes, And it's a combination of two skills. It's a combination of skill 3 that we just learned, how to find limiting reagent, and skill 2, which is, how to use a 4-fraction kind of equation of conversion factors. Okay. So the first thing we do is we're going to find that this was present and this was present as our reactants. All right, and they're wondering how much, let's see, how many grams of iron. So this is going to be what they're concerned about. How much can they really make if one of these is limiting? Okay, so first we find out which is limiting by saying Fe2S3. There was 241 grams available, and then the carbon, there was 15.6 grams available. All right. Now we divide them by their molar mass, and Fe2S3's molar mass is 207.9, and carbon's molar mass, you might remember that one because sometimes you can memorize some of these, is 12, right? Alright, and after dividing those two, you get a number. And the first answer was 1.16, and this one was 1.3. Alright, now it says divide the answer by the coefficients of the balanced equation. So Fe2S3 has a 2, and the other reactant, carbon, has a 3 in front of it. Alright, so those work out to be 0.580 and 0.433. That means this one's our limiting reagent and this one is in excess. Okay, so now we know that the carbon's information needs to go here. That's our known. So 15.6 grams of carbon, just pure carbon. Okay, now I'm going to go ahead and make my brush. Here's the handle of the brush and the bristles of the brush. And it says how grams of iron can be made from this amount of carbon. So here's our unknown, grams of iron. Grams of iron. Okay, and I'm going to make done. Okay, so all of this has to do with iron. So I can go ahead and say iron has a coefficient of 4. Put the 4 there. Carbon has a coefficient of 3. Put a 3 there. Alright, I need to do molar mass of iron. So the molar mass of iron is 55.8. Okay, now I need to put a number here. Okay, so this is still about carbon, and this is grams on top, so I want gram on the bottom. That is a G, believe it or not. Doesn't look like a G. Grams. Okay, so I look up the molar mass of carbon, which, like I said earlier, you start remembering some of these, is 12. Okay, so now we've got something in all the spots, and now we're ready to punch in the calculator. 15.6 times 4 times 55.8. Now we're done with our numerator, so now we have our denominator. Divided by 12, divided by 3 equals, and that answer will go there. And so 15.6 times 4 times 55.8 divided by 12 divided by 3 equals. So 96.72 is our answer, but because we have 3 fixed here, we would like to round that to 96.7. So that's saying that if you only have a limited amount of carbon, you only expect to make this amount of iron.